Hey everyone, so today I have somebody joining in from the University of Alberta. Solved around 150 leak code questions. So yeah, want to introduce yourself? Like, are you starting to interview now? So you want to do some practice or what's up?
Yeah. So my name is Matthew. I'm from, or I go to the University of Alberta. I just have some interviews coming up, and just I'm getting a lot of O's, and I've been doing bad on them.
Yeah,
I've just been practicing, trying to get up my skills, so I don't mess up opportunities when they come.
yeah.
So
I mean, if anyone
yeah,
doesn't know, University of Alberta is a pretty good school. It's one of the top schools I'd say in Canada. So I'm happy that you're
yeah.
getting interviews. What year are you in?
I just graduated.
Oh, okay, nice, nice. So now
Yeah,
you're trying to go for full time.
yeah. Trying to find full-time stuff currently.
How did you do any
Yeah,
internships or anything?
I have one. Like I honestly slacking a lot doing my degree. I should have been more aware or trying to get internships, but I wasn't.
It's
I did
fine.
have one, but yeah, it's making the job search right now harder than it needs to be, but
Yeah.
it's fine.
No, I'm happy you're
Yeah.
getting interviews though. So, are they? What kind of companies are you aiming for?
Um, I'm just usually I have better luck with like local companies, ones that are closer, like around Edmonton, um, which is where the University of Alberta is.
Yeah.
Um, yeah, some stuff in Capital One.
Nice.
That one's in the US. But mostly local stuff. I had an OF, I had some stuff on Amazon, but I did so bad. That's when I knew I needed to start practicing lead code after the
Yeah.
Amazon the way I had. So yeah.
So what are your leak code skills right now? How good do you think you are?
I think maybe medium level or not. You've probably know the Need Code 150 list.
You done it?
Yeah, I did went through the whole list. So I've just been grinding out lead code recently for the past 2, 3 months.
Yeah. All right. Okay, we're gonna simulate a real coding interview. I don't know if you've ever done one, but pretty much you're given this interactive code editor where we're gonna be writing all of our code. I'm gonna ask you one to two
Okay,
questions, about 20 minutes per question, and yeah, we'll treat it like a real coding interview, and let's see how you perform.
okay.
Okay, let me think of a good question. Um, so okay, so what I want you to create, this is gonna be pretty vague, so we need to work through all the requirements. But I want you to create me a doubly linked list class. Doubly linked list. Does that make sense?
Or is that the whole question?
Yeah. I want you to create me a doubly linked list.
Okay, so you just want okay. I can go ahead in Python, right? That's good.
Yeah.
Okay, so
So what's the strategy for implementing this? Are you familiar what a linked list is?
yeah. So oh sorry, my bad. I should have explained first.
Yeah.
Okay. So the way I'm gonna do this is I'm gonna start off by having so a linked list essentially I have a node that like connects to another node, and that's how a linked list is formed.
Mm-hmm.
Usually, a singly linked list, you can only have them going in one direction. So you have one going to the next, going to the next, but a doubly, you can have them going backward as well as forward.
Mm-hmm.
So that's what I need to implement here. So in this class, what methods do you want me to implement? Do you want me to have like I'm guessing a way to initialize it to be empty,
Mm-hmm.
and you want an
Yeah.
insert method as well?
Okay. We'll say we want to be able to add at head, add at
Okay,
tail. We want to be able to then remove from head, remove from tail,
Okay.
and then search, and then um, add at index. So
Okay.
that's
And
what
for
I
that,
need to know for now. Actually, let's change this up a bit. Sorry. Let's remove from head, remove from tail, remove from index. Add. So these are the 6 operations that I want you to create.
okay. And I'm guessing the remove functions will only be called if there's at least one node in the linked list, like the remove from head and remove from tail.
Yeah, exactly.
Because if there's, okay, so I'll just start out by initializing it.
So I'll give you a quick hint right
Uh,
now that we should probably try to iron out the approach before coding, just because in case it gets complicated, we need to make sure that everything's planned out, and that's usually the best way to approach these interviews.
okay, so um, so I'll start off, I guess, by the adding at the head. So what I'll do for then is I'll just take the current head, then I'll just move the forward pointer or the next pointer to the node I'm adding. And that new node, I'll edit the previous pointer to point to the head. So
So which operation are you talking about?
the added head.
Okay,
I'm gonna implement this one first.
sure. You can add a head.
Oh, wait a minute. First, I actually need to create a node class here for every single node in the linked list. So for this one, I'll have this be. So I'll need um I'd have 3 values, right? I'll have the value of the node. Start off with 0, and then I'll set that to be the value. And then I'll have next and the previous for every single node. So, or actually, yeah. So I think that's how every node's gonna look like in the linked list. It's gonna have a value, and then it's gonna have what it points to in the previous one. Um, of course, to initialize the W linked list, I'll need just create one node to be the head. Um, problem is, hmm, actually, maybe I should just start by implementing the added head. Do you need something to initialize the W linked list?
What do you think? It all depends on your design, really.
Okay. Um, 'Cause if I want to add at the head, I can't really add if there's nothing there to add yet. Or then maybe, oh, I could just check actually if there's a head. So for the added head, I'll check if there's a head. If there isn't one, I'll create it. Or if there is, then I will just go ahead and append the new node to it. So this one will be add, add. Then for the value of the node, I'm guessing for the linked list, you just be given like a a number, right? Like an index for each node in it.
Yeah, we can just pass in a value.
Okay. So I'll check if there's a head for the W link list, then I'm able to just easily do the connections. So if that's there, then I'll do self dot. So actually, first I need to create this node. So I have, this equal to this node, the value. Why is this not working? Oh, okay. So now if the head exists, then I just need to connect the head to this node. So the head dot next, put to this new node. Um, and then the new node dot previous to the self dot head. And then remember head is unknown. Um, just because I didn't initialize it. Yeah. Then let's set the head here. Okay. So if there's a head, then I just make this connect to the new node, then the new node previous connects to the head. And then I need to, uh, I think that's it. If the head does not exist, are you able to hear me?
Yeah, I can hear you. Just watching,
Okay.
just analyzing.
Good. If the head goes, then yes, I just move the next value to the new node to the previous one. And I don't need to change the head here because the head already exists. Else, in this case, then I'll just make that head equal to this new node. Um, I think that's it for this method. Just double check. New node is equal to the new node with previous sub to that, sub to head is equal to the node. Okay, I think that's done for that method. Is that good?
So we're adding at head. So what are we doing? We're creating a new node, and we're pointing the
Yeah,
head dot next to the new node.
yeah.
So, well, we want to when we say add to the head, we want this value to be the new head.
Oh, okay, I misunderstood that. Okay, so if we want this new value to be the new head, then
So pretend we already have this linked list. This right. We want to add 0 to the head. It should go here.
oh, okay, I see. Then I need to do this. Uh, oh, no, okay, I need to change this a bit around. So this new head. Oh, okay. So I need to flip this around. So actually, I'll save this. I'll use this one. I'm guessing this one will probably be for add a tail. Let me edit this around then. So then that means that this new node dot next is actually going to be the head. So point to the old head. And then, yeah, it's gonna point to the old head. I think that's just it actually. The next points to the head. The previous is gonna be no because there's no thing behind it. And then I need to edit the self.head previous. And then now, okay, those. The next equal to self.head, self.head. Head dot previous is equal to the new node, and now the self.head now becomes the new node. Else, if there's nothing in the list, then the new node just becomes the head.
Self.head.previous because a new node. Okay, self.head. Okay.
Okay, I think that's good for. Is that good for added head?
Let's try dry running it. Try dry running it right here with a few examples. Say we want to insert one,
Okay,
two, then three at the head. How'd that look?
okay. So if you want to insert, for example, zero here at the head, so we'll create the new node. So we'll have a new node here with value of zero, and the next will be equal to null, and the previous will be equal to null as well when we create this new node. And then here, if self.head, here this already has the head, so we'll have this will return true. So we enter into this block. Now this new node dot next, or actually maybe we'll go here now. The new node dot next will now be equal to let me post this here.
You just
Will
try
now
writing
be
it
equal to
down
the
here.
self.
It's cleaner in
Oh,
these comments.
okay, okay. So I'll start off by trying to. So with the zero value, we're in here. So the node would have been zero. And then we'll do new node dot next is equal to self dot head. So
Well,
this will now point
we
to
want to
one.
insert one, two, and three here. This is what we want to insert. One, two, then three.
Oh, into the list.
Yep.
All these values in.
Yep. Say we call it
So we'll start.
insert one, insert two.
Okay, I see. So for the first call for insert one, what we're gonna do is we're gonna create the new node with a value of one, and then if self dot head, since nothing was added to this list yet, there'll be no head. So we'll enter this other block here, and then we'll just set this one to be the head. Now when we go to insert two, we'll create the new node for two, and since there is a head, we're gonna put new node dot next is equal to the current head. So two is gonna point to one, and then this self dot head the previous. So the previous head was one. This one is now also gonna go back to two. I don't know how to put an arrow going. Oh, maybe I'll just go like this. And then two now becomes the new head.
Okay.
Now, if I go to insert three, I'll create the new node with a value of three. And then since the head does exist, this new node the next will point to the old head, which was two. And
Nice.
then the old head creep's value is going to point to the three. And then the self that head now becomes three.
Okay. All right. So if I wanted to debug this, as in like print out the list, could you write me a function that prints out the list?
Okay. So go print list. Take in yourself. Oh, why is it? So wow self dot head. So while we have the head, we'll print the value dot head dot value, and then self dot head is equal to self dot head dot next.
Okay.
I think that
Is
is
there? Could you just or could you see if there's anything that could go wrong by printing the list this way?
okay. So while I have a head, then I print the value of the head, and I set the head to the next value. Um, oh, wait a minute. Okay, I see what's going on. The problem is that I'll always have or self that heads equal to self. I'm gonna be messing up the list. So I want to preserve the list, right?
Yep.
This way, if I'm like modifying the head, then I won't be able to print the list again in the future
Exactly.
because this self dot head will be equal to null. So I actually need to create a temporary value here. So I'll set that to self dot head. And then while I have that value, I'll print the current value, and then go to current next. Okay, while current print current value, current is equal to current dot next. Okay, I think that's good now.
Nice. Okay. So let's go test this code, like run it on these insertions and then print it and see.
Okay, so um, okay, so I have one and two, three, and then print rest. Okay. Not why does it look like that? Let me see. Oh, yeah, I mean, yeah. Okay,
Nice.
so it does work.
Cool. All right. Let's move on to the next. Add a tail.
Okay, so if we want to add a tail now, we'll need a tail here. So we'll set the self.tail equal to none. Um, oh wait a minute. Okay, this becomes a bit more complex with the self.head. So here, when I create the head, if it doesn't exist, I think I'll need to modify the tail here as well. So um, self tail will be equal to the self.head. Oops. Yeah, because if I'm adding for the first time at the head, then that means there's no tail, so I'll need to set the tail as well. Okay, so now, um, let me go back. Now I can do the dash add tail. Okay. Now I'm trying to add at the tail. Okay, so Similarly, I'll create the node that I would like to add. I'll just do that. Okay. If there's a tail, then what do I need to do? I need to set the tail, the old tail, the self.tail.next equal to this new node, and then new node dot previous be equal to this self.tail. Okay. And then self.tail equal to this new node. If it doesn't exist, then I need to do something similar. This would be the first node, so I need to do something similar as I did here. So actually, I could just copy this. Self.head is equal to new node, self. Yeah, that'll be fine. So I'll just double check this. So if self.tail, if I have a tail, then I put the next pointer to my new node, then my new node, the previous value to that old tail, and then I make the new tail my new node. If I don't have a tail, that means I don't have any value in the list. So I set the head to be that value, and I set the tail to be that value as well. The head. So do you want me to dry on this one as well?
Yeah, let's try run this as well.
Okay. So, or how do you do those? Was it like this?
Triple
Um,
quotes.
okay. Okay. So here, I guess we'll do it with 1, 2, 3 again. So if I want to add one, originally there will be nothing in there. So I'll create the head equal to the one, the tail equal to one. Actually, maybe I should have value. I should keep track of the head and the tail as well. So originally these are both equal to none. Tail is equal to none. Okay. So now I want to add one at the tail. So what I'll do is I'll create the new one. And since there's no tail, none, I go into this other else block. And now I make the self.head is equal to this one, and self.tail equal to self.head, which is one. So the head and the tail will be one, and the node will be one. So now I go to two. I want to add two. There is a tail, so if self.tail, one was a tail, we enter this first if block. If tail, or self.tail.next. So you go to new node.
I think your function works. Let's add. Let's just write a test case for it here, and then move on to the remove. I think the remove part is gonna be interesting.
Okay, add that tail. Okay, so it does work. Okay, now the remove from head. So def remove from let's just remove head. Actually, okay, so I want to remove from the head. Okay, so if there's no head, then I can just return myself. God, head. Then I can return. There's nothing to remove here. So if there is a head, then I want to remove from the head. So what I need to do is, if I want to remove from the head, I need to keep track of what the new head will be. So I want the new head to be equal to self.head.next. So that would be the new head. And then if that's the new head, then I wanted to also disconnect from the old head. So self.head, the previous will be equal to none. So now I've disconnected it from, uh, is it giving me, it's not, okay. So I disconnected it from the old head.
Sure.
And then here, I'll need to edit the head of the W linked list. So now I have self.head equal to new head. Oh, wait a minute. I need to account for the case if I'm deleting the last one and might need to edit the tail. So here, okay, if there's only, this works for any node if it has more than two values. But if I'm deleting the last node, I'm also need to gonna account for the tail because I'll be deleting the tail as well. So if not, if there's nothing there, then it's also equal to none. Okay, so south of head equal to this new head. If there's nothing, I need to account for the fact that I'll be deleting the tail as well. So I think that's it.
New head equals
But
self
not,
dot head dot next. Okay. Okay. I mean, is there anywhere? Let's see. Yeah, go ahead and try it out. Go ahead and test it. I think there could be a slight error here. I'll give try to look for it.
south of head is equal to this
Maybe not.
new
It's not
head.
like a logic error, but it might throw exceptions.
Oh, new head dot previous. Oh, okay. I see where there could be an issue here.
What?
So if there's nothing here, new head is equal to self.head.next. But if there's no next value, then I'm trying to access the previous element of a none. So that will give me an error here at this line. Um, so what I need to do is new head is equal to self head.next. So actually, I need to just check if there's a new head here. So if not new head, so if there's not a new head, then self dot tail is equal to none. Then I'll just return new. Just double check this. So new head is equal to self head dot next. If there's nothing there, I set the tail as well to be none, and then return. Else there is something there. So I set the previous value to be none. Oh, oops. Self.head is equal to new head. Um,
Okay. All right. Let's see. Try implementing it, or sorry, testing it, running it on some tests.
okay. Um, so, so I'll add in those values, and then I'll just try removing remove from head. I'll just call this twice. Okay. So it is working there. Let me try this again. Okay, seems to be working. Let me test it when there's nothing
Or could you
in the
modify
list
remove from head
intro.
to actually return the element that got removed, so we know?
Oh, okay. Um, so that will be equal to self.head.value. So this would be the value that we'll be removing right now, the head value. And then it's just non-hero self-details equal to none. Here we go, return. Uh, Actually, I can make this code a bit cleaner. So if there was a new head, then what I actually need to do is make this new head dot previous equal to none. And then actually no, I'll leave it the way it was. That's fine. So we could do just run it again. Oh, I need to print the values. Okay. So add one, two, three, and then remove, remove. Mm,
Is it working? One, two, move one.
So
Let's do
maybe
this
this would be
instead.
better to test if I.
Let's see, this is an easier way to. This is an easier way to print it out. Give me a sec. Just so I could see it better too.
Okay.
DLL print list. Let's just say here every time. This. See how this looks. So add a tail. Or sorry, let's just print list at every single. Sorry, let me just. In between each one, we'll just print the list to just make sure we're doing everything as expected. So we add one, we add two, we add three. Okay, we remove from head, we get two. Okay. It's looking solid. Okay, implement. How would we insert into a random area? Like, say we wanted to insert to a random index. How would you do that?
You want to insert to a random index
Yeah,
in the
write me a function
okay,
that takes in an index or
okay,
insert, add a
yeah,
specific index and a value.
okay. So I take an index and a value, and then I'll insert. Okay. So F insert at index self index. So what I'll need to do is if I want to insert at an index, that means I'll start off at the head. I guess I could start off at the tail as well, but I'll just start off at the head. And then suppose I want to insert, like, for example, the value is 2, then I'll need to move 1 ahead. So I'll need to like stay at the oh, when you mean index, is it 0 index or is it 1 index?
And zeroth index, zero, like we're gonna be zero index. So zero puts at the head, one puts it
Okay.
at the first, like index one.
So I'll just traverse the head until I get to the index where I need to insert it at. Then from there, I'll create the node. Then I'll put the previous index pointing, the next pointer pointing to that node. And I'll put that node's next pointer pointing to the node ahead of it.
I mean, go ahead and
And I
implement
need
it.
to
Let's
know.
see.
Okay, over here. So, so if I want to insert at an index, for example, the index is 2, then I need to go up 0, 1. So I need to go up 2 elements. So first, so it's index minus 1. I need to go up minus 1 elements. So parent, let's go to self dot head. Mm, range, traverse, and just equal to, so I need to go up to the elements.
We could assume that index is always correct, as in we're not gonna try to insert outside.
Oh, okay. Okay. So my current element is going to be equal to current dot max here. Okay, so if the index is always correct, we go to self dot head. Okay. So now what is current dot next? The problem is that current dot next will be known. So so if I have a head or if I have proper value, well, this value should always be true since the index will always be correct, right? But at the 0th position, it's possible that there's nothing there. So if there's nothing there, and this is just inserting at the head, and we'll just, what is it? We'll just be adding that. Just be adding at the head. Self dot added head. Um, this value. So we need to go ahead and create the value. Okay. So I'll handle the case if there was nothing there. We just need to add it at the head. Now, if there was something there, now we could go ahead and now add it into the list itself.
If not current,
Uh,
add it to the head. What do you mean by that?
So the current equal to will be the self dot head. If there's nothing at the head, that means we'll just be adding, we could just use the previous added head function to add it to the head. Um, Maybe I should check for this here.
What if we did already loop through and we got to the end?
Sorry,
If not current. Yeah, I just don't
it
get
should
that
be up
case.
there actually. Um, like my current element, this would be the self, will be the head for the list.
Okay, that makes more sense.
And if there's no head, then I should just put it here. I should have put this higher up. And then now I just loop through until I get to where I want to insert it into. And then while I'm there, then what I need to do is, okay, so I need to keep track of what was ahead of it. So ahead would be equal to current dot next, and the past value, if the past should be equal to current, ahead would be equal to current dot next. So this new node, and all I do is maybe I should do the past first. Past dot next. This would be equal to the new node. Let's click this new node here with the value. Okay. Now this past the next value will be equal to the new node. Um, so that handles case going forward. And then now for this new node dot next.
Okay, we're pretty much at time, so I
Um,
think we got to a good place. How do you think you did? How was that for you? That interview?
uh, it's a bit weird coding and talking at the same time. Feels a lot different.
Not
I'm
used
not
to it,
used
huh?
to it.
Is your first time actually
Yeah,
having to do like code in front of someone?
yeah, this is my first time.
Okay, I see.
Yeah,
Yeah, honestly, for your
this was
first
really
time, you did really good. You just, I think you just need to just come up with or just follow a more clean approach when going through interviews, as in make sure that when you get the question, clarify first, clarify any assumptions. So you want to talk through,
okay.
clarify, just ask about the edge cases. So for example, for this question, if I first got it, I'll be like, okay, W linked list. Then I'll run some clarifications like what functions should I implement? Okay, if I'm trying to remove from the head and there's nothing, is throwing an exception fine? So just or and then what else? What are we gonna insert into the linked list? Is it just strings? Is it objects? Like, clarify first. Just make sure that you know everything about the question and there's nothing. You just clarified it. You did the due diligence. Does that make sense?
Okay.
And then after you clarified the question, you want to start ironing out your approach inside of the comments. So start talking about how you'll approach the question before you code and get alignment on that. So yeah, with this question, just mentioning, okay, we're gonna create a couple node classes, and I think this one is better. Sometimes this one is just pure coding, so you don't need to talk that much about it, but just ensuring that you have an approach before you get coding and making sure the interviewer understands that you're going the right direction.
Okay.
And then after that, after you clarify, after you mention your approach, then you start implementing it. And I think you did a good job implementing and explaining your thought process. And yeah, you're able to do a lot of the things right, like creating the node class, printing the list was you're able to catch some exceptions by just looking at the code without running it, such as the different null pointer exceptions. So I think you did pretty good. Just make sure that you follow a good process. Like you take the same steps every time you're going to do a question. Does that make sense?
Okay. Yeah, that makes sense.
Do you have any questions for me?
No, I think that's everything. Thank you.
Sure, yeah,
Thanks
I'll
a lot.
send you a list of how you should actually approach these. But I think overall you did good.
Okay.
It's more just like getting these done faster. So being able to work faster,
Okay.
getting it done faster.
Okay.
But yeah. And look up one thing I would look up is Sentinel nodes. Try to look up Sentinel nodes. It'll make your doubly linked list way faster or way easier to write, especially when handling removing when the list is empty and you don't have to do this extra part of updating the tails and heads at the start.
Okay.
But yeah, look up Sentinel nodes. Have you heard of that before?
Is it like dummy
Yeah,
notes? I think
exactly.
these
So
are
if you put a if you come to the drawing here, if you put like a dummy head, like you create a dummy head and a dummy tail, right?
okay.
Are you in the drawing?
I think it's low. Oh, I
Oh,
see it now. Yeah.
like if you create a dummy head and a dummy tail,
Yeah.
and then say we just have a variable saying that our list is size 0 and pointing to this. Every time you add to the head, all you need to do is you don't need to worry about no edge cases. You just add to the head like 1. And like all the inserts are the same, right?
Oh, and then okay,
And
I
then when you
see.
keep
Always
adding,
preserve these dummy.
yeah, and then the head and tail always stay the same. If you want to print out head, you just look at head to the previous. But every time you want to insert, you just keep inserting to the right of this head. So if I want to insert 2, and then every time I want to print out tail, I just print out tail dot previous if the value is greater than 0. But that way we don't have to ever keep maintaining who the head and tail is. We could just like the head
Okay.
and tail the just it just makes it a lot simpler. You'll see when you try it. Try making sentinel nodes a head and tail sentinel node and then defining these in the init function.
Okay.
Yeah, that's kind of my advice there. Otherwise, good job. Thanks for taking the time out.
Okay.
And I think you have another one
Thank
scheduled
you.
next week.
Yeah.
All right, we'll see how you do next week.
Okay.
Do something else.
I'll see you then.
Or is it next week or tomorrow? Let's see. Where you going tomorrow? All right.
Hey, let me check. I think I have one next.
I think
There's one tomorrow.
yeah. You booked one tomorrow.
Okay.
Okay, I'll catch you, man. All right.
I'll see you.
Good luck
Thank
to
you.
you.